Okay, so I'm going to talk about the challenges of ambient agents. Oh, yes. So I kind of introduced myself a little earlier. Fred Patton, Senior Developer Advocate at Auth0. And yes, so does anyone know what ambient agents are?
Like an actuator.
An actuator. Yeah.
Something for you in the present place.
Yes, and it runs continuously. Normally, well, we'll get into that. So let's just jump in. Okay, so I don't think I'll be making any forward-looking statements, but if I do, take it with a grain of salt. It's probably not accurate, so don't bet the farm on it. So yeah, framing the challenge. So sustainability. When we're dealing with AI, obviously we could spend a ton of cash, and for it to be sustainable, to be fast enough to matter, cheap enough to run, governable enough to trust. There's all kinds of ways to lose money with AI, including not to spend on token. It could just be because of some terrible issue that you created or massive loss of funds. So as most of us probably know, a large proportion of AI projects fail. I think I saw the number was near 90. And there's a lot of reasons for that, including the data not being AI ready. So let's think about ambient agents, which have been popularized by Chase of LangChain. And in January, I think it had a big uptick. So normally our co-pilots, live in sessions, right? We ask it something, it does some work. Okay, maybe a lot of things happen and it talks to other sub-agents. Maybe there's multi-agents going on. But at the end of the day, it kind of lives and dies in that request-reply cycle. So, and in this case, you get a pretty good idea about how much spend these different interactions are costing you, what can happen. The intent is kind of straightforward because someone asks something, it might misinterpret it, but basically the overriding intent is what the user put in, whether it's botched or not. Ambient agents, on the other hand, live in systems. So you're connecting them to listen to sources. And so you say, okay, connect my AI agent to a event stream. Does that sound like a good idea? That'd probably be a very bad idea because those things are very busy and you wouldn't want to be hitting an LLM to look at every event. So, but on the other hand, it makes a lot of sense for ambient agents to be proactive and monitor events. So how do we deal with that? Well, if they're connected to an event bus, then it's a stream processing problem. And so you have to tackle that first. And once you've done that, you can basically provide a stream at the right frequency, at the right kind of resolution, and with the right context for that. So that's what we'll be getting into. So yeah, so it all comes down to context, as everyone is talking about context engineering, completely vital, right? We've learned that if you don't give an AI agent enough context, it won't be able to do what you're asking it to do. And if you give it too much context, the performance goes down, right? Usually we think more is more. Oh yes, okay, the new model handles all these tokens, so let's just throw the whole thing in there and ask it questions. Well, it starts to not do very well there, and there's a lot of opportunity for it to kind of go off schedule and go on random tangents just from little bits of unnecessary stuff in the context. So, event streams are a raw signal. And what we'd have to do is basically, for whatever type of system that we have, kind of maintain a running state, right? So this is basically your optimized context, like, okay, all these different counts, all these different kind of metrics where you understand something, your different policies in there, And then as you get events, you're updating that state. And at some point, based on your policies and your heuristics, you will be ready to say, okay, here's an event. It looks like we need to take action with it. And we're going to also use the the streaming context so that the agent will know any other surrounding events that it needs to look at, what's happened next, how things are sitting, and able to make an intelligent decision. So continuous context. So, it's high throughput. You've got the fire hose. You definitely don't want to connect any agent directly to that fire hose, as we discussed. And the cost of doing that is enormous. And then the latency. Like, even if you had tons and tons of endless money, you still wouldn't want to basically involve the LLM with a bunch of context and calling it frequently for, latency issues, right? So I'm going to talk about a design pattern called context-aware governor pattern. This is where you basically are taking your raw event streams and you're feeding in the policy, your fine-grained authorizations and those type of things, and you're putting into a governor. And what the governor is doing is basically taking the minimal state based on those actions that an LLM would need to do the job and no more. And in doing that, when it's ready to emit, it'll emit to an actual sane stream that the Ambident agent can connect to basically get context that it's really ready to act for. So that has to be as much as possible outside of the LLM space. And you can also use small language models. You can also use the custom code, but generally no model is better for as long as you can go. And there's all sorts of ways to get down to this. So how are we doing this? A lot of times in stream processing, you're basically accumulating the deltas. Normally when we think about deltas, we think about, okay, we're just sending the differential data. But here at a higher level, we're really talking about deltas in terms of the different events and the different thresholds. It could be some certain patterns, like in context complex event processing, where if you see this thing, and then you see this thing, and then you see this thing, then you need to basically add the information and take action with it. It could be rolling windows and certain kind of thresholds where somebody maybe needs to take a look at something. So based on the domain, it's capturing that succinct state and checking policy in terms of when we are ready to basically emit an event. So with the heuristics, we are basically filtering out a lot of noise. If you think about IoT and a lot of other models, a lot of the data is actually redundant. You've kind of seen it before, or it's kind of expected or not at a threshold where you really need to worry about it. So there's tons of opportunities to basically just filter out most of what's coming from your event stream. You use your policies to constrain the focus, and then over time, the context converges to relevance. So the goal here is feasibility. It's the cost, it's the correctness, it's the individual policies, the data privacy, all these type of things. So it's got to be incremental, iterative, and basically governed. So we'll talk about identity and governance. So Auth0, as I alluded to before, an identity management company, customer identity management. Identity is a big facet. So if we think about RAG and the different if you think about large language models, okay, what's it been trained on? We can look at pre-training, post-training, and all these different kind of things, but there's training time data, and basically the LLM is answering nicely based on the data that it has. Then the point is, okay, but it doesn't know my organization. It doesn't know the data in my organization. So then you use RAG to basically query your company databases, query your docs, and give it a little more intelligence. Well, now users really want to be able to have agents that take actions, and these are using tools. But to take action for you, it's got to have your context, right? It's got to basically know where your data is, right? We might be using Gmail, Stripe, Slack, all these different kind of apps. And so it's cool that the agent can go now and execute and do a bunch of stuff for us, but there's kind of a problem, right? What if it makes a mistake? And do I really want to basically give it full access to these accounts that is connecting and hope that nothing bad happens, right? And maybe you said, okay, yeah, take my Stripe. I really want to have this thing, go buy it, okay? And the agent goes and buys it. But then now it still has your credentials, and suddenly you're finding out you're getting charged for some other type of stuff that you didn't want to get charged for. So when agents know about the identity, we have to have a way to ensure that it's you and basically get authorizations so that we can say that, okay, I'm not giving you my creds. I'm basically use something like a token vault where the vault manages the creds, and it will basically, based on sensitivity and based on user options, it will basically give the agents short-lived tokens so that they can basically do very scoped work for a limited amount of time. So if an agent is still wanting to do something that it shouldn't do, but there's security behind it, it will fail. And so that's what we want. Yeah, so accountability. When we have code that things are muddier now, right? When you have system tasks running, it's code someone wrote. So when the job running my code goes down or does something horrific, my phone rings, right? Or I get paged, I get a message, hey, Fred, your tool is going crazy again, and you got to get over here and deal with it, right? We know who's responsible, and we know what that code's supposed to do. It's a different thing if I'm going and creating an AI agent, right? Because, okay, I didn't tell it to make this certain decision. I gave it policies, I gave it instructions, but there's not the determinism. And so that's why things like asynchronous authorization are pretty important. And so when the agent is taking action, we need a way for it to have to basically ask permission in any kind of sensitive operations or if any kind of thresholds happen. So in the security world, there's basically client-initiated back channel where you'll get a message on your phone, you get the context there, and then you're basically going to approve or not approve. And if you approve, the agent can go forward, otherwise it can't. So yeah, agents must act on behalf of users. So agent identity plus delegation matters. Without identity, you lose control. You don't know what happened in the logs, and it's a mess. But if we think about it a little bit more, agents don't just necessarily act on behalf of a particular user, like just saying, okay, use my data, but an agent probably needs to have a boss when certain constraints, and then that could be a different person. It could be a manager or whoever would be responsible for an employee doing that job. That's what the agent would be doing. So in terms of Auth0 and where it fits into this is Fine-grained permissions is one aspect where you've heard cases where you ask an agent, it queries, it returns data, but it's returning data that you shouldn't have access to, right? And normally we would do something like role-based access control where we can say, okay, all the engineers, you can get this stuff, all the accountants, you can get this stuff. But with all the different relations and all the different contexts, that is generally not enough, right? You really want to be able to decide, based on your model and all the kind of situations. Okay, in this case, if he's logging in from this unknown IP address, or if he's logging in outside of work hours, or if she's in a different location and she's trying to do this type of thing, it maybe doesn't qualify. Sender constrained tokens are a very important thing. There's a couple cases that are used. One is called Depop, which is demonstration of kind of like right now in MTLS. Basically, these are your messages are signed to your identity. So it's using PKI. So if you're sending a request to something, it's the responsibility of the receiver to basically make sure that it's actually coming from the proper identity before taking action. So if an attacker comes in and gets hold of your token and starts issuing stuff, if it's protected with a sender constrained token, it will fail and be rejected. And that's important. As I've talked about with Token Vault, with the scope short-lived access tokens, and then step-up authorization, where maybe something's over a certain dollar amount. Maybe it's something that's going to affect a bunch of users, whatever that is. In some cases, you got to basically activate the human in the loop to be able to take action. Okay, trying to check where I am on time. So here's kind of showing a kind of a flow of what that can look like, where you're seeing the user data that might get accessed and give permission to. You have whatever external signals coming from the events, and then they'll go into the governor, where they will be consolidated, minimized, remove information that shouldn't be in there, or really getting to the minimal things so that you can get something actionable for your Ambident agent to have some nice, clean context to work with. So it will have to basically, call the APIs and be properly constrained. So let's see, we'll skip to closing the loop. Yeah, so I'll just say one more thing on the audit trail, and because I'm wrapping up, eating up the time. So if we think about AI agents taking action for us, it's usually for automation. If we think of it, okay, if we want to basically scale work and let the agents do things that people were spending a bunch of time doing, then probably that there's a lot of information in your audit logs, right? This is kind of establishing norms. And if you give a human a bunch of permissions and a bunch of APIs it can access, the human is just going to go and basically use what it needs to do the job, right? So in this over provisioning case, because of norms, the human knows, okay, I'm going to get fired, or this is crazy, or whatever. But an AI agent is happy to go use all its kind of resources at hand. And so one approach is basically making sure that the permissions and APIs being used together are properly isolated. So for this type of task, we should see these type of permissions being used. I mean, these type of permissions should be had, and these type of APIs should be used. And if the agent is deviating, then you know, those permissions should be revoked and it should be stopped from taking the actions that it was about to take. So, thank you.